So there are three basic ways we can get an inconsistent system in three variables. These first two are basically the same, so I'm going to discuss them together. In this figure, we have three parallel planes. And in this figure, we only have two parallel planes, which means that one of the equations that we have must describe the same plane as another one of our equations. Either way, all the planes we have are parallel. If we look at the equations in standard form, this is very easy to spot. In both cases, all the coefficients are the same. So it's easy to see that if we combine any two different equations on either one of these lists, we'll eliminate all the variables, and the resulting equations will be false. So here, it's easy to spot that we have an inconsistent system because all of our coefficients are the same. So that's one of the things that can go wrong when we have a system of three equations and three variables, and it's very, very easy to spot that it's happening. It's also a possibility that we have two planes that are parallel, and if that happens, well, they'll both intersect the third plane, but the intersections will be parallel lines. So these two lines won't intersect anywhere. There won't be any points where all three planes intersect. If we write a system like that in standard form, well, it's easy to see that these first two equations give us parallel planes. We see two equations that if we combine these two equations, will eliminate all variables, and the resulting equations will be false. So, in this case, again, we have an inconsistent system because two of our planes are parallel. They never touch each other. And again, this is easy to see because we have two equations that when we combine them, we get rid of all the variables. There's a third possibility that's a little bit harder to spot. And it's even a little bit harder to see what's happening here. We have three planes, and every pair of planes intersect. The intersection of every pair of planes forms a line. But then the lines themselves are parallel. So the three planes form this little triangle here. And there's never a point where all three intersect. Now, this is trickier because when we write our equations in standard form, this looks fine, right? When we write our equations in standard form, there's no obvious way to eliminate all of the variables by combining just two of them. But watch what happens when we try to solve this. So I'm going to try to solve this system. And I'm looking at the variables. I need to decide which one I want to eliminate first. I'm not going to use x because that has all different numbers for its coefficients, but y and z both have coefficient 1. I'm going to choose to eliminate y. I could equally well have chosen z, but I'm just going to choose y this time. So let's see. I'm going to start by combining 1 and 2. And it looks like if I take -4 times 1 plus 2, that'll eliminate my y term. So I'll take -4 times 8x plus y minus 3z is -4 times -3. So multiplying that out, I get -32x minus 4y plus 12z equals +12. I'll copy equation 2 underneath that, which gives me 10x plus 4y minus z equals 10. Adding down the columns, I'll get -22x, I get a 0 here, plus 11z equals 22. Looking at that, I noticed that those numbers all have an 11 as a common factor. I'm going to divide through by negative 11 just to get standard form. In standard form, I'll have 2x minus z equals negative 2, and I'll call that equation 4. Okay, so I eliminated y once. Now I want to eliminate y again. This time I'll involve equation 3, and I think I'll keep using equation 1. I think if I multiply equation 1 by a negative 3, that's going to work for me. So I'll take negative 3 times equation 1 plus equation 3. So let's see. Negative 3 times 8x plus y minus 3z is negative 3 times negative 3. So negative 24x minus 3y plus 9z equals 9. Then I'll line up equation 3 underneath that. 2x plus 3y plus 2z equals 2. Adding those together, I've got a negative 22x, and then I've got a 0 term, plus 11z equals 11. Again, I notice I have a common factor of 11, and I'm going to divide that out. So, and I'm going to divide by negative 11 to make my leading term constant. 2x minus z equals negative 1. And that's equation 5. So notice what happens. Our new system of two equations in two variables, well, what happened here was those two lines are parallel. When we got our system of two equations in two variables, that's an inconsistent system. If we have a system of three equations in three variables, and we combine them to get a system of two equations in two variables that ends up inconsistent. The original system was also inconsistent.